Kia ora koutou, katoa, ko Monty Ingoa. You'll see my name is Montgomery. No one actually calls me that, but I still write that out of habit. I'm going to be like dual wielding laptops because I can't get Teams to ever work for my computer. I think it doesn't like me. And yeah, so I'm the web and platform discipline lead here at PaperKite. Well, not here, but and we're an agency that build mobile and web applications and the systems that kind of sit behind them. We do a lot of like UX work as well. So it's, and we're best known for like a petrol kind of company app, not Z Energy's one, and not some other one that has some kind of weird gambling element. But you can pay for petrol, coffee, and it was done a long time ago before like contactless was a big thing. So it was pretty cool. We've also done stuff like Ripple, which was a contact tracing app before the government one came out to help with the hospital sector. And it was like a privacy first design. So yeah, we've got a big passion for helping people and kind of doing societally impactful work where we can. And that's kind of where we've been moving. So that's my spiel about where I work. I kind of feel like I meant to do that, right? And I'm going to talk about a project called Supernova and how we made a big change safe, basically. So I'm just going to hit X on both of them each time. Yeah, I originally started like putting AI generated images on the left because like, what do I find for the images? And they just all look like some fever dream, and I just got rid of them. So you get strange emojis. Cool. Yeah, so just before I kind of started coming here, I just ran this by my delivery directory. It's like, hey, you got to remove the client from all the slides. So I'm going to try not say who this is for. So it was a client of ours who were changing loyalty. It was a big change. We kind of built a mobile app for it. Has back-end functionality supported systems. Some old loyalty was being replaced by a new one. And we had a legal obligation to do the big release on at like midnight because lawyers make decisions around these things, not developers, which I guess probably makes sense. Yeah, and so we had like old apps that can't show it, and new loyalty required login, link step, and so forth, and I just kind of trail off, and I'm not actually going to read it all because it doesn't matter. The point is, lots of change. Cool. And so just a little bit of context, about the timeline, we kind of learned about it in 2022. We're going to have like a quarter of like requirement stuff being worked out by clients, and then we're going to have like 8-9 months to do all the work, which is pretty exciting. It was a good amount of time, and then there'll be some UAT before Christmas and a big release. And it turned out requirements went about twice as long, and so we ended up getting like 3 months. UAT needed longer, and it was a bit of a big bang thing, so it was quite an ordeal. I originally wrote this, I started being a bit like more like project leadery kind of approach, and I'm like, I kind of want to talk about the tech and stuff instead. So yeah, just so some context. So it was a really highly coupled change, coupling bad maybe. In this case, it probably was some elements of that. It was about 19 years ago now that it was built, a lot of it. And any change was shotgun surgery. Anyone heard that analogy? You don't want to do surgery for shotgun is what I think, but I think it more means that making the change affects everywhere. But I don't know how you do surgery if it's not shotgun anyway, so I couldn't recommend. So all the 3 main flows are affected. Pumps, fuel, coffee, and car washing. The flow, the main flow, the pumping fuel kind of flow was untouched in about 4 years. They were kind of old and they had really limited testing, and there was like highly stateful stuff, lots of integrations, lots of error scenarios. It was like asynchronous polling. And the team was all new, about 2 years. So there was some change, and basically none of us worked on the old system. So it was quite a high risk change is what we identified. So I'm going to kind of go through and I'm going to talk about each section about what we kind of did and why we did them. So the first thing I'm going to talk about is power tests. Just seconding Matthew, pretty much. So why am I talking about tests? So all these big changes, we realized we basically weren't going to be able to just write this and get it right, particularly with really kind of limited testing. I'm a big advocate of make the change easy and then make the change, which kind of I'd like to extend to make the change safe and then make the change. So it was really going to be really hard for us to know that everything was right, basically. So what we kind of did is we took some of this old existing endpoints and this old existing stuff, and we wrote better tests for it, basically. We just started off with revamping the tests, making the change easy before we made the change. So the way we approached that is we kind of did like request integration tests. It was a nice balance of like complexity and effort. Like you do really big integration system tests can be really expensive to run. We also had a lot of old code that we were wanting to like replace, and so we didn't want to get down do lots of unit testing on older systems that we were going to like move and rip out. So we approached it by doing really big kind of just like integration tests on endpoints and focusing on that, and we were describing how it affects the users. So really trying to capture the user requirements of each of these endpoints, and what the app needs from them, and tests. And we're going to do that all for the existing version, and then we were going to copy the tests forward for the new version, and then implement to meet the tests, which was pretty cool. So yeah, doing that allowed us to do that, implement the tests for the new no loyalty system, using all the old tests, like all the old functionality described in test, making the change really easy. So when it came to the QA and UAT integrations, we basically had no feedback, which was really, really like rewarding. And when we had such a tight time constraint, like you really lose a lot of time if you have lots and lots of back and forth between QA and UAT feedback, particularly if there's like multiple parties involved in integrations. You've got different vendors, and yeah, there's a couple of other requirements I'm like missing out. Like we had integrations not available till quite late in the project, so we need to make sure things work before we change it, when we don't necessarily always have them all available. But yeah, so we it also allowed us to basically change existing flows. So when we're making this whole big new change, like our goal is that we're going to have all our new stuff that we're building over time merge frequently. So so we wanted to merge it frequently, and we want to do that so without breaking the existing functionality and the existing endpoints. So all doing these kind of approach to testing. It also allowed us to then kind of do decoupling deployment from releasing. Oh, wait. Oh yeah, so I was going to talk a little bit. I had some examples of some of the tests, just to show some of the ridiculousness of some of these things. I had to last minute redact all the names, so don't mind my color-coded squares. We started off with just like simple like describing the test. We checked that it matches like an OAS schema because we're working with mobile apps, and with mobile apps, a kind of complexity you have is you can't go onto people's phones and like force them to update. People don't update their phones, the apps on their phones, they leave them around, and you don't want to break old apps. And because of that, we have really tight like regression requirements. We don't want to make changes and have the APIs deviate. It's really easy to do, and sometimes with like mobile apps, with the typing and such, there can be like you're going from Ruby to like a really more strictly typed languages. You can get some of these data incompatibility issues where something is a string and not a none or something, and it can create some problems when it gets passed and whatnot. Yeah, so we would write a straightforward valid tests. Like it responds to a 201 response. It calls a matching schema. It creates the session. It creates a pending session checking like state and stuff. And these are the closest we can get to like the user flow from a request integration speed, which is pretty cool. We described like our integrations. Like we log the event in this event logger system. We describe the different serialized site information that's in this case, which is quite a big, each of these things expands to a decent area. And then we have all the error handling and so forth. We go through, we have a bunch of like general errors that we have, and they're going to be across multiple tests, so we use like include context, which is a really nice little feature of like RSpec, is you can share context between multiple requests if you have like a consistent error handling approach that you want to apply on all of them, and it's particularly useful when you have like lots of requests that are in a flow. And yeah, just a little snippet of me trying to get some code in it. Really good. Yeah, so one of our approaches as well is we didn't use VCR. Some of us had painted with VCR before. We approached it in a kind of interesting way. We wrote factory responses for requests, and we had a real simple kind of HTTP mocking layer. Factories do create a bit of coupling. You have coupling to your factory of how your tests work. If you make them random enough and good, it's pretty hard to introduce coupling, but it can still be complicated. But what it did allow us is it allowed us to make really consistent tests in lots of different edge cases that we couldn't necessarily do. We don't have control over the systems that we were integrating with, and so we can't simulate all the different scenarios. But what we could do is we could get examples of requests, and we could use those example of requests to really simply make basically mocked responses for all our different scenarios. It made our integration tests really easy. It made them really readable too sometimes, which was really good. And we had to do this anyway because we had to review all the requests that we were working with. Yeah. Cool. 15 minutes. I can't remember when I started. So I'll talk a little bit about decoupling deployment and release. So there's a huge amount of change in this release. And we had to change it on the dot, and with existing apps couldn't show loyalty and so forth. And so what we didn't want to do is do 9 months worth of work and then try a big bang merge it at the end, and then just suffer. Yeah, that would be awful. So we kind of, I'm a big fan of like continuous integration. I wanted us to try merge frequently. I like to think that you don't have to go through all the pain of what other people have already gone through to like learn the lessons from it. You can just kind of take what really smart people have already gone through and learned as a good practice. And there's a report, there used to be this DevOps report, I think it still might be running, where they kind of did a statistical analysis on what IT delivery practices result in faster delivery. And one of the big things they had was low branches and merging frequently. It was a really good indicator. And so I like to think I'll just take their word for it, and I'll try merge frequently, because I also experienced a lot of pain with long-running work that's been separate from a code base. And in our case, we would have still having features and hot fixes and whatnot, and then to be worked on the main trunk of work, the main branches. But we also need to be working on this big release that changes this huge loyalty system. It is coupled through everything. So that was kind of why we wanted to do this decoupling. So, just a missing point there. So basically we could deploy changes that were verified and not release them to the public, because again, we can't do it until it's good to go. So we used feature flags, which is pretty common practice. We hadn't done it heaps before, so it was a little bit of a new process for us. We've been playing around with it a bit, but for those wondering, I'll talk a little bit about what they are. But they're basically just like a Boolean check or something that if this user has this feature enabled, run this bit of code. And in doing so, it's a bit more complexity, but you can make your changes. We had to then make sure we make our changes regression safe with we have a QA team and lots of tests that we have. And yeah. So it also, one of the cool things is doing this, we could turn on our features per user. So when we're doing this new loyalty system, we could then turn it on for one user in our environment, test it out, see how it's working, make sure that when we turn it on for that user, it doesn't break other users and so forth. Experience. Yeah. So we can work on both systems, or existing systems and Supernova. And eventually, when it comes to it, we can release with a flick of a switch, or would have been ideally maybe a rolling process, but no, flick of a switch. So, fair. Cool. Yeah, so this is just a little bit of code snippet of what feature flagging for us kind of looks like. We use Launch Darkly. It's a pretty cool system for managing feature flags. We used it in a pretty simple way. We mostly use Boolean feature flags, but you can see here, like, unless feature flag on for user behave like v1 controller. That's a weird one because we couldn't change this integration, so it had to behave two different ways. There was one in like a webhook thing that had to operate differently. So a bit of a bizarre constraint, but that was how it was dealt with. And here is where I've, I think, carefully omitted everything that I meant to. Where I have all the feedback features, and say if the feedback feature, if we're on Supernova's loyalty, you have feedback on these things, and if it's the old one, these are the feedback kind of symbols which correspond to feedback forms and stuff like that. And yeah, it's pretty cool. Yeah, so the next thing I want to talk about, which kind of relates, these all relate, as you'll notice, I'm more of a rambler than a presenter, is merge often. So I talked about that DevOps report, but basically the things that they kind of talk about in this is, I think there's a book called Accelerate that covers it quite nicely. I'm a big fan of that one. I haven't read it, but I've been told about it. And then, so I think you've read it. I'm a big fan of something I haven't read, but I got the snippets out of it. I used summaries of it, and then yeah. So if someone else has read it, they can also recommend it. I don't know if I should recommend it then. I took it out of the work library and I just kept it on my desk at home for ages. So maybe I like passively absorbed something from it. But they basically talk about like loosely coupled architectures. This architecture wasn't particularly loosely coupled, but trying to get fast feedback loops. So that's like why we want to merge often. You know, why we use feature flagging, so we could do that, and so we could test it and get our QA and UAT feedback really frequently. Feedback loops also testing as well, why we did so much effort on making sure we actually really described all the existing functionality before we kind of jumped into like ripping everything out and changing things. Because we want to be able to know if we're broken stuff before we go give it to someone else to like manually simulate if something's been broken in like a live, like a UAT QA environment, which would be a lot of pain. Yeah, they talk about continuous delivery, trunk-based development, and automated testing and deployment. They were their big kind of sections, but again, haven't read the book, so probably not the best summary. Yeah, so we want to merge often so we could de-risk it. I talked about, and it also means it's more efficient. Less time like wasting around like merging things. If you have some refactoring that you've done, you want to be able to share it. You don't want to have it's stuck on one branch and separate from like another version of the code, because every branch is a duplication of the code in a sense. And what I've always found is that like if you have really big barriers to like merging, you find that people create larger pull requests. You lower the quality of your code review. People are less afraid, or when you merge often, people are less afraid to do refactoring PRs. They can get their refactoring out quickly. They know it's not going to be stuck off somewhere, and they know that refactoring often can create conflicts if you're not careful as well. So merging frequently just really helps with that, from my experience. Yeah. So yeah, we merged often. That's what we did. Used feature flags and versioned endpoints to make things regression safe. So newer functionality we only exposed on new endpoints, and we kept the old ones as they were. And it allowed us to work on both systems and not wait 9 months to merge and then fair. And yeah, then have UAT kill us, metaphorically. Yeah, so I just snapped on a diagram of us like planning out roughly how our branching works. We do a really simplified Git flow, or an extended continuous integration, probably not really, more of a simplified Git flow. We don't have release branches or anything. We just have a staging branch and a main branch. Our main branch is our production, and we just do a semantic tag off that, and that does an automated deployment. And we have staging branches where we make release candidates off, and they're just, again, semantic tags and do automatic deployment. And then we technically have a third internal environment. So staging is where QA and UAT happen, and internal QA and external UAT are happening on the same environment, which is not ideal, but it is a technical constraint that we have to deal with, one of which feature flagging makes it a lot easier as well. And then the internal RC tag, which is our internal release candidate, that's just where we get a tag we can move around, and it will just create a deployment from that revision, and deploy it to a live environment where we can play around with it, because we were quite constrained on 3 environments. And that's roughly how it works. Yeah, seconding everything Matt said about small branches, we use a lot of interactive rebase to do this. We use stacked pull requests as well, which is great. I'm really happy that GitHub added the feature where they changed the base branch. They didn't originally do that, and I would merge into dead branches all the time because I wouldn't check, and then I'd have to recreate the pull request. I don't know if that's just a me problem.
It wasn't just a you problem.
It wasn't just a me problem. Cool.
It used to be more manual.
Yeah, it used to be more manual, right? Yeah, I got into that practice, and it's really great. Cool. And the last thing that we really did to kind of make it safe again was we overhauled our observability. So, I guess what observability I'm kind of referring to is our ability to see what's happening in the system, to see how it's behaving under load, to see how, and it's really important when you have like a system that's doesn't exist in isolation. You can't just like read database records. It's like talking to other systems, talking back to it. You have like queues that are doing stuff in batches and all that shenanigans. You want to be able to know that it's working. So yeah, we wanted to be able to really know what is happening during the release when it happens. There's going to be all these new systems going online, and we want to know if like something's just 500ing and just straight dying, or we need some weird response codes and stuff like that. Gives us confidence, and we can then, again, that fast feedback loop, like identify issues early and we can react quickly. Yeah. So we approach this. We use one thing that's kind of a little thing. I really love JSON formatted logging. Weirdly love JSON formatted logging. I really like log rage. It's a nice little gem that just takes, for Rails applications, takes your logs, doesn't make them multi-line, slaps them into one line in a JSON format. It can make just like using your kind of log aggregation tools a bit easier to find things. But it also, when we use CloudWatch, which is AWS's log tool, it allows us to do like special syntaxes for JSON to like inquire into the logs and do like searching into them and like analyze the logs using like a JSON parse syntax, which we can then use to create filters like metrics. So it counts specific application logs over time, and we can see status changes of records, like say when we have the fueling flow has lots of different states in it, and it has requests that the apps trigger, and it has requests that another system triggers on us, but there's also polling involved, and there's also some asynchronous stuff. It's a bit insane. And we can kind of monitor that through some of these graphs, which is really cool. I also talk about HTTP log, which explicitly says do not use in production. We do use it, but we use filtering on it because the system it's not just, if you've got a really independent system, you just have like your Rails route logs coming in from like your users. Our system kind of sits in between two things mostly, and if you just saw the user request, you wouldn't really know what's happening outside of that. So we use a really filtered HTTP log. So we log also all the HTTP requests and in the same way that like Rails will log params, but with like heavy filtering. And that allows us to really see for like one user what's happening on a certain request. We can like trace through, particularly if a request has a couple of calls in it. But yeah, it allows us to have some sick graphs. What I wrote. Oh yeah, we have like a hierarchy of them, which is pretty cool. Like, I'll show you one in a sec. And like we have like an overall graph of our system health. We can see if like this integration is playing up or this one. We can check the new loyalty flow that we're doing for the release, and we had pump one for the fueling, which had like 14 different graphs on it for the different state transitions, which was crazy to look at, but really useful. Pretty much. Okay, sweet. So this is actually what it looks like in code, sort of. So this is what like our JSON logs might look like, formatted prettily, of course. And we take those JSON logs, and in AWS CloudWatch we have log metric filters. So your logs in CloudWatch, they come through as like streams from all your servers. They're grouped into log groups, and your log group might be like the std out error of your containers running on ECS or something. So like your Rails logs in this case from your Docker containers or something. And then for each group you can create these things called metric filters with some limitations, which basically just do this that JSON path rule, and they will count something because of it. So you can count 200 requests or something like that. In our case, what we do is we count the requests and we aggregate it. We'll have the dimensions as a status code, and so we can see all the graphs of the status codes from a certain endpoint over time. That's pretty cool. And then we did all that through Terraform to generate them because there's boatloads of them, a couple hundred. And yeah, and so you'll see over here on the right, I just took a screenshot of like, these are what they look like. They're like HTTP status code 200, that's like general system one. There's like user awards v4 endpoint status code 200s. And you can then like click on it and you can see you can graph it over time. There's some QA graph, not production, over time. And what that then lets you do is crazy stuff. Yeah, so I kind of wanted to show this in action, so I ripped out the access numbers, and these are not the actual labels of the things. We have much better titles for our graphs, rather than sign up flow A step 1. But we have this flow that goes between all these different steps. And what we can do is we can see, like, so you've got like flow A goes step 1, step 2, and then step 3. And then flow B just goes step 1, step 2. And what we can see is we can see if they're behaving or if there's errors coming through. And we have like crash monitoring as well, but this is more just seeing like the HTTP status health, which is a good general alert, particularly if you have things like gateway timeouts happening that sometimes don't get caught. Or in this case, we had this little 409 error, which is a resource conflict error. That is a standard error in this case. This is a linking step, and what will happen is if someone is already linked with this loyalty program on another account, they'll get a 409. And we noticed heaps of 409s quite early in this release. And what we realized is, all right, well, there's a problem, first of all, because unless people are all trying to use their same loyalty accounts. We didn't think that by the amount of them. And we identified there was this race condition, which we wouldn't have identified otherwise because it actually has no effect on the users. So we had an error, no user effect, just a race condition that was creating some extra load, and we could identify it because we had this graph showing a disproportionate amount of this specific error code, which is pretty cool. And another example, we see this big red line of doom. Yeah, so I made it red because it's bad, and it was bad. But there was an incident, like a downstream integration had an issue. And so what we had to do is we basically had to change our flags to do one of our like kind of break glass scenarios temporarily to make it safe, to make the system in its like no loyalty state. And you can see the traffic die off. You'll notice there's still some traffic. That is because there was a caching problem with the mobile app's feature flags, so their record of the flags. So they had two sources of flags, which is a lesson learned if you have flagging. Yeah.
Which graph was that one?
Oh, sorry, the big red one.
The big
This-
one. Okay.
Yeah, so bad. It's the 500. You'll see down here, it's the 500 status code, and it's for the unlink call. Yeah, and so it's pretty cool. Really helpful. Cannot rate observability high enough, but yeah. So just to recap. So Supernova, which is a forebodingly named release, it was a big bang release. It's this is basically our approach of how we made it a bit safer. We used a lot of testing. We tested it and made it safe before we made lots of changes to the system. We decoupled deployment from releasing so we could test existing stuff and new changes at the same time. So we could merge often, so it was less work and more efficient. And de-risk it. And then we made sure we can see what's going on when it actually happens, because you never know what's going to happen. You don't have control over everything. So it's good to be able to see if something that you don't expect goes wrong. So yeah, that's me, I think. Thank you. Cool. Any questions? There's a lot. I'm more of a... I hope I went on time, I think, yeah. Is it good on time?
I think so.
Yeah, cool. Sick.
What were you using for the graphs?
That's CloudWatch. Dashboards, yeah. I made them manually. You can just kind of manually add them together, and then I realized that would be super painful. And you can actually just export it as JSON, edit the JSON, and I just used my editor's multi-cursor to make it a lot faster in duplicating it, and made them that way. And then, yeah, we decided not to do them through infrastructure as code because they would be a bit tedious and it wasn't really worth the effort. But the metrics we made through code. But yeah, CloudWatch is really powerful, underrated. I'm sure maybe like Datadog's stuff probably does it cheaper, or maybe easier, maybe not, definitely not cheaper. Definitely not cheaper. We don't use that because it's expensive. Although I would love to, yeah. Cool.
Did you have to go through many iterations, or did you kind of get the graphs you wanted straight away?
We did like a bit of a workshop of like what we wanted to know. So we like kind of, how we approached it is we're like, as something goes, so we know something goes wrong, where do we look? Like what are we gonna look at? And the general way of us telling was like, okay, let's just look at logs, look at the requests for that call and see if we can identify some non-200s. You know, it's a common thing like, hey, someone's had an issue, is around this time. Like, okay, let's go to roughly that time and let's like use a JSON query the log to make sure, double check ones that don't have a success status code, see if they're there, look at those. You know, if we don't get specific information, that is. Yeah. So we kind of approached it that way. But yeah, no, we didn't have to play around with them too much because we just approached it initially from HTTP status codes. But you could easily do it based off like query params or HTTP log params if you want it as well. So the pump one has some stuff around status changes, which is based off a body element, which is useful for us to see if there's lots of transactions that are going into the wrong state or something. Yeah.
So did your changes affect the real pumps, the hardware in the world?
No, we were removed from the hardware. I'd say thankfully. Our system is, it's not, there's like two kind of back-end systems. We don't do all the transactional stuff exactly. We do kind of middleware a lot of the requests. It's a bit of a back-end for front-end, but we also are kind of masters of identity and some other things, and a lot of the promotional stuff and various things like that. So yeah, no hardware, unfortunately. Well, fortunately, I'd say. Yep. Yeah.
500 is such a tiny string.
Yeah, so great question. I think I know the answer. I'm going to try to remember it because this was a while ago now. Yeah, no idea. No, I can't remember.
So I was wondering too.
It's so perfect, right?
I'm just wondering if there's like continuous data or if it's literally
It might be CloudWatch rendering it funny because sometimes it like lines 2 points that are like got a gap between them. But no, there was. Yeah, I have no idea. That shouldn't necessarily be a straight line.
It's all right. It's just curious.
Maybe it's not exactly straight if you look at it carefully. Yeah, I actually just went in Photoshop and it was like, there's a reason for it. I can't remember it. I'm sorry. Oh, it's going to bug me now, so I'm going to have to go with that out. Yeah. Cool.
What did the actual release time look like? Were there people online?
Yeah,
That switch?
straight midnight, because it's like a New Zealand specific system. Yeah, people were on it pretty quick. This is like, what is this? This is 3 a.m. So I thought about this. I was like, man, I should have had the actual release one, because you could see, one of the cool things on the release, you could see the system switch.
Right.
And so you can see us going from one old system to the new one. And so you know that it works. I know, like, you hit the button so you know it works kind of thing at this point, right? But it's nice to see that it's working, you know, because even if you did it, you'd still go check logs and such.
Yeah. I guess I was just curious if you were that confident that you were just like, we're just going to go to sleep, not worry about it.
I did go to sleep,
Sit in the morning, but
yeah.
we were watching.
We had someone watching.
Yeah, that's fair.
Yeah, but I did go to sleep.
That's fair.
But we were pretty confident on it,
Yeah.
and we had alerting on it. So my watch screams at me in the night, and it's right by my ear, and it's terrifying. There was, when this happened, because you can see it's quite early. The person monitoring it, we had like it all planned out. Our rollback if something goes wrong. Like, well, it's not exactly rollback because legal constraints, you can't actually roll back. So it's roll to a different state.
Yeah.
Worked without a charm. So we switched our stuff over, and it all worked as intended. Other than the little mobile caching issue with Firebase, because Firebase remote config, which the mobile teams were using for some flags, you don't really have control over when it refreshes, strictly, which was a bit of a lesson that we learned through that. Yeah.
How did you actually manage the switchover? Was it kind of enabling the feature flags so everyone had it, or did you kind of like clear them out?
We had to enable it all at once. Yeah, so like logically allows you to do like rolling or like segmented flagging, so you can release it to these people, but we had to roll it over time. We had to do it all at once. So you basically just see on the graph of like 3 hours before this, it just goes like off a cliff and then up a cliff, which was frightening, but good. It all worked. It stopped working over time is what happened. Like, it didn't break it straight away. This was after several hours. But yeah. We did also, it was a cool thing about the feature flagging is we had production testing happening for months beforehand, so we could actually turn it on for specific people in advance, and they could go with real systems, which is really important when you have like physical sites and physical integrations and hardware. Which is a unique constraint. Also, these graphs, minor detail is the 200s and the non-200s are left and right aligned. Small detail, so it looks like the red line is way over the green line. It's not, it's actually quite low. The reason for that is because, ideally, your success status codes are way higher than your non-success status codes. And so every other graph line would look like a flat line next to thousands of greens and like a couple of others. So we right and left line the axes. So you can see things. Like the purple line isn't actually that many, it's like way down in below the green. It looks way more dramatic though this way. Yeah.
So you've got a few more than two things showing up on some of those graphs, but you said there's left-right axes. Is there 403s somewhere in there, or are they just 403s for the bottommost right?
There's 403s for that, pretty much. Yeah.
If there were 403s on that graph, would they be smaller than the other two?
They are on the right line too, so they'll be in the same unit as the red line. Yeah, so if, like, for example, in this case, there's a real big spike in these 500s due to this error, and that is 500s, might I point out, is 500s of the party we're calling. So our system still had an error handling for it, it's not that 500ing. If there were 403s on that, we would capture them there. Yeah, but we usually wouldn't log the 403 because we check off, it's an OAuth kind of client credentials exchange, and so it's checking the validity before it actually goes in 403s. But if you have a user hitting endpoint, like this one here, I think you can see there's like little dots. Those little dots I'm pretty sure will be 403s or 401s, which will be triggering the reauth flow for the mobile app to refresh its old Bero token. There. Cool. Yeah?
So as part of this big release, did you also like re-platform the thingy? Or?
Yeah, we did, because it was such an old system, we actually did rewrite a lot of it, which made it was a de-risk thing as well, as like us not wanting to carry forward an older system that had not wanted to do the whole shotgun surgery approach and extract it. So I definitely wouldn't traditionally recommend just rewriting things. Like you don't want to have to do that. It's not great. It was in that point due to over time and it being an unexpected change that I guess people didn't forecast the loyalty system being ripped out, and it wasn't designed for that. So yeah, because we didn't want to tackle like improving a lot of the unit tests as well. We rewrote a new system. We improved the error handling to be a lot easier to understand. The old error handling was very hard to understand, and so we had to unpick that, which is why writing the test first was actually a really great exercise, because we were testing that our understanding of it was correct, because if the test failed, it meant our understanding was wrong in that case. So it was kind of a bit of a backwards way of testing, but using it to understand a system that you don't have defined, which was pretty cool. So yeah, we rewrote a lot, but it's still in the same Rails repo, missed this. Yeah. Do you have a?
Yeah, so this is all API traffic. You didn't have any like web traffic.
Yeah, this is all API traffic, which is why our tests, like even our request tests, are like that. They're for the user, but they're for the app. The app is the user in the API context kind of thing. So it's more we're trying to describe what the app needs. Yeah, there is web stuff as well, but this is just the API stuff for this one.
So one of the issues I found with doing status codes in Rails is when you get like a 401 and a redirects.
Yeah.
Trying to see what that, and particularly with log rage, there's some weird specific bug that log rage doesn't handle the edge case very nicely.
Yeah, log rage has some weird issues at times. Yeah, it doesn't handle some situations very well. You can. Yeah, we don't have like file uploads. Log rage requires you to do like wildcard routes, I think, to rescue a lot of those situations. I think. I might be remembering that wrong, but I think that's how it asks you to deal with it, which can conflict with active storage. But we didn't have file uploading, so we didn't have. I think we could put in the recommendation to prevent some of the routing errors and stuff like that. But no, that might not be the redirect one though, actually. But yeah. Cool. Awesome. All right. Thanks, guys.